Okay, so this time we're going to look at if we go backwards and see how you're, if you're getting the hang of this idea. So why don't I do the middle one? I'll do sine. I'll walk you through it, and then I'll see if you can come up with the others on your own. So sine theta equals 0. Does anybody know, what does that mean? What am I looking for if I want to know where does the sine of theta equal 0? Sure, Alan? So close, so close. Yeah, y is 0, right? Because sine is the y coordinate on the unit circle. So I want to know, where does the y coordinate equal 0? So if I go and look at the unit circle, which is getting rather messy, maybe I'll tidy it up a little bit. Then if I was at y equals to 0, what do you think? What angles would it be that have a y coordinate of 0? Sure, Andrew?
2 pi and pi.
Yeah, so there's one right here, and there's another one right here. So this one would be pi, and this one would be 0 or 2 pi, depending on how far around we want it to go. So one thing you'll notice here, it actually gave us a range that said go from 0 to 2 pi. That's the only reason I picked 0 instead of 2 pi. But you are correct. 2 pi would be an answer. So for this, I have two answers. It could have been the angle 0. It could have also have been pi, where the y coordinate equaled 0. Okay, see if you can figure out what the other two mean. Okay, so cosine theta equals to -1. What does that mean in terms of the unit circle? All right, go for it.
X equals to -1.
Yeah, we're looking for where x is equal to -1. So if we look on the unit circle, the only place that has an x coordinate here, which is -1, 0, is the angle pi. So that means the only possible angle it could have been between 0 and 2 pi would be theta equals to pi. Okay, so what about the next one here that says, what if tangent is undefined? What does that mean if it could? How could the tangent be undefined? Sure, Joey.
Divide by 0.
Good. So what we mean here is we mean divide by 0. So how could you divide by 0? Because these are the clues to finding the answer.
X is 0.
Yeah. So tangent is equal to y over x. Then x must be equal to 0 for this to be undefined. So if we go back up, where is x equal to 0? Well, here's a point right here. This is the point 0, 1. And here's a point right here, 0, -1. These are the angles pi over 2 and 3 pi over 2. So that could mean there's two possible answers where tangent's undefined there. It's at pi over 2 and 3 pi over 2. Okay. Clear as mud? Getting better? Yeah, it's just, I don't know, it's a goofy expression. Okay, so the next thing we're going to take a look at that has to build on the same idea. This is to take a look at where things are positive and negative in the different quadrants. This is going to connect us back to reference angles that we did the other day. So just to remind ourselves, it's probably worth putting in the little margin here that this is y, this is x, and this is y over x. So in quadrant 1, if we're thinking of the y coordinates, okay, so let's think, if we're in quadrant 1 there, will sine and cosecant be positive or negative?
Positive.
They're going to be positive because y is positive. Okay. How about the x coordinate in quadrant 1?
Positive.
It's also positive, yeah. So tangent is positive divided by positive, so all of them are positive. Okay, so if we move over to quadrant 2, and we say, okay, sine and cosine, is that any change there?
No, positive.
Y coordinate's still positive, so is this. Okay, how about cosine though?
Negative.
Yeah, the x coordinates become negative, and a positive divided by a negative makes the tangent negative. So the only one here which is positive is sine. So So I'm going to let you finish off the rest of the table, and then I'll catch up to you. Okay, so if I was in quadrant 3, I'm over here, then the x and y are both negatives, so that means these are both negatives. Negative divided by a negative makes the tangent positive. Okay, and the last one, if we were in quadrant number 4, I have a negative value for y, a positive value for x, so a negative divided by a positive makes the tangent negative, and the only one here which will be positive is cosine. Okay, so you need to be able to reproduce this table, but the good news is you don't need to be able to do everything we've just worked up to. There's some helpful acronyms to help you remember this. I know that at this school some teachers do something like this. They call it the cast rule, where they say this is the way it goes for cast. So quadrant 4 is the cosine, all, sine, and tangent. And it just kind of works nicely that it's a cast, a word that you know. The thing I don't like about it is that it starts in quadrant 4. Okay, normally it's nice when things go 1, 2, 3, 4 instead of 4, 1, 2, 3. So here's the one that I learned. I like this one. If you call this all students take, and it could be chemistry, or since we're in calculus class, why don't we call it calculus as well? Okay. So that little acronym, all students take calculus, it can help you remember all, sine, tangent, cosine, for which quadrant's going to have a positive value. I've heard there's tons of them out there. It just depends where you went to school. This one I've heard too is kind of funny. Add sugar to coffee. Okay. Again, it's just to help you remember so you don't have to write the whole table out. So what you'll notice, right, is that they only become positive in one of those spots. So this tells me, for example, in quadrant 3, tangent is the only positive. And cotangent, of course, now that we have reciprocal ratios. Okay, so if sine was negative and cosine was also negative, then what quadrant must the angle be in? 3. So you guys, future rocket scientists, how did you come up with that so quickly? Okay. Oh, okay. So, but why not quadrant 1 if tangent has to be positive? Two of them are, the other two are negative. Okay, so they did a little bit of problem solving in their head, and that was very creative. One thing that I do usually is I go like this. I'm not a rocket scientist. I usually need a little method to walk me through it. So if sine is less than 0, that means y is less than 0. So negative puts me here, quadrants 3 or 4. If cosine is negative, that means x is going to be negative, so I would be over here. This is the one that's 1. It has both agree that it could be negative there, so this is a quadrant 3 angle. Okay, so if you can't creatively problem solve it in your head, then see if you can figure out how to use this little graphical method of checking which quadrant the angle's in. Okay, did anybody come up with a quadrant? Let's see here. Brian, how about you? Not yet? Carney, did you come up with one? 4, yeah. So 4 is correct. If we are cosecant less than 0, cosecant is paired up with which of the ones you're familiar with? Sine. So if cosecant is paired up to the sine, then that means y would have to be negative. Okay. Cotangent is obviously paired up with tangent. So if I want a tangent to be negative, it means I'm going to have to be here or here. So this would be a Q4 angle then. Okay, so here's how we connect it all back to what was important to us and what we had learned yesterday. So yesterday I told you the most important thing you were doing was reference angles. A lot of build up to it. Reference angles are going to be huge to us. So here's where we need to use that information, and just to show you how it works, I got a few examples cooked up. So 60 degrees, this is a quadrant 1 angle, and it has a reference of also 60 degrees. So I'd like you to work out the same thing for those other three angles. Which quadrant and what's the reference angle? Okay, so you should have got quadrant 2, and again a reference of 60 degrees. Quadrant 3, a reference of 60 degrees. And quadrant 4, a reference of 60 degrees. Okay, so what's the cosine of 60 degrees? Yeah, half. What about the cosine of 120 degrees?
Negative.
Negative a half. And 240?
Negative.
Yeah, and then the last one is a half. Okay, so we mentioned this before when we looked at reference angles. The value was the same. The only thing that could change was the sign. So, for example, it could be positive or it could be negative, but it has the same value of a half. Now we have enough information to say whether it's going to be positive or negative. Okay, if we look up here, okay, it says cosine is positive in quadrants 1 and quadrants 4. If I look at the answers I got, quadrants 1 and quadrants 4 were both positive values. Okay. In quadrants 2 and 3 where it's negative, I ended up getting the negatives here. Okay. So this means we can take all of the angles you can think of and we can shrink them down to just their reference. Okay, we just that one quadrant from 0 to 90 degrees. All we have to do is be sure we apply the right sign to it. Okay, so here is the way you can think of this. Okay, instead of working with the angle 200 degrees, I could say, what's its reference angle? Any ideas? Yeah, it's 20 degrees for its reference angle. Okay. And now I also have to ask myself, the reference has the same value as the cosine of 200, but it may be incorrect. It may be positive or negative. We need to double check to see what will the cosine of 200 be, positive or negative? How did you know that? Right, so we need to know the quadrant. So if this is quadrant 3, the cosine is going to be negative. So instead of solving for cosine 200, I can think of this as the cosine of 20. Okay. That's how I can write an equivalent angle and not have to work with all 360 degrees, or even more if we didn't have coterminal angles. Okay, so you try to work out how could you rewrite those angles so that you don't have to deal with anything other than reference angles. Okay, so what's the reference for 430? Yep, 70 degrees is the reference. Which quadrant will the original angle be in?
1.
So if it's quadrant 1, then what will the sign be, positive or negative? It's going to be a positive, so this is the same thing as the sine of just 70. So, remember I told you radians was going to be our, whoops, too far. Radians was going to be what we work with for the most part. So we should be able to repeat this process. Do you know what the reference angle is going to be for 4 pi over 3? Yeah, pi over 3 is going to be the reference. Can you figure out which quadrant? 3. Yeah, quadrant 3. 4 pi over 3, that's like pi plus pi over 3. So it's into quadrant number 3. So in quadrant 3, the sign is negative. This will be the negative cosecant of pi over 3. Okay. And finally, with the secant, negative 2 pi over 3, what would the reference be for negative 2 pi over 3? Yeah, so if we ended up adding pi back to this, we'd get a quadrant 1 angle of pi over 3. So which quadrant is negative 2 pi over 3?
3.
Yeah, you're going backwards this time. So here's 1/3, 2/3. So that means I'm going to there, which is a quadrant 3 angle. Secant is a negative, so that means this will be the negative secant of pi over 3 if I was to rewrite it. Okay.